It's my pleasure today to welcome Mr. Calvin Pennamon. He comes to us from Northrop Grumman, and he's currently the director of the Overhead Persistent Infrared Exploitation Systems Operating Unit for the Payload and Ground Systems Division of the Space Systems sector. In his role, he does a lot of amazing things that he'll tell us about. A little more background on him. He started his career in the U.S. Air Force, where he was actually an officer in the Space Command's Defense Support Program. He's earned his degrees from Clemson University and Regis University. So he has a very wide background in biological sciences, computer science, and also systems engineering. Welcome, Calvin. Looking forward to your presentation. Please go ahead.
Hey, thank you so much, Mark. And really, thank you everybody for taking time out today for this conversation. As he said, I am been in the space systems. I've been in space, whether with the Air Force, Space Force, or with Northrop Grumman my entire career. So it's really been a joy from that perspective. What I wanted to just kind of outline for everyone is a little bit about what Northrop Grumman does in a space systems perspective of how our activities are geared, how our overall organization performs, and more importantly, just some of the wide range of things that we perform from that perspective. Because like all organizations, we are simply always looking for new personnel, new opportunities for employees, young entrepreneurs, young people really looking to drive the future of the industry. And one of the great things about space is there's a lot of future and a lot of opportunity from that perspective. So I have been based in Denver since 2003, either in the Air Force or with Northrop Grumman. Now I have several facilities here in Boulder, Colorado. So therefore, always looking to make sure we're developing that great relationship with our universities, with our students, and everything from that perspective. So that's really what I wanted to kind of start with. Before I kind of go into that, a lot of people don't know what Northrop Grumman does, but we are a global security and technology company. So when we talk about global security, a lot of people ask, what does that mean? That's a wide variety of things. As you can see here, I'm in the space side. The satellite that you see there is a geostationary OPIR satellite, overhead persistent infrared. So that means it's looking for heat signatures or things of interest from that perspective. But we also are a large aircraft company. The B-2 bomber was built by Northrop Grumman, the replacement for that. Advanced networking, it's all about how you communicate. So therefore you have a large amount of computer science, as was mentioned by Mark, is what my degree is in, as well as cybersecurity, all across the board from that perspective. Strategic missiles, we are a part of the replacement for strategic missiles for the Minuteman, in which we're going to what we call GBSD. To where we're constantly looking for ways that we are able to protect the nation or be a part of that from that perspective. And that's across the board, whether it's surviving it, creating new weapon systems, adding defense nature for our country, or figuring out how we can observe what is occurring from that perspective. And there, what you see in that sensor EW on the bottom right is an actual phased array radar that's placed on the nose of an F-35, in which that is used in order to see threats that can be upcoming. All of this is a part of that broad portfolio of an organization that's seeking to do whatever it takes to help the nation or its allies in having the tools necessary to protect our warfighters and to protect our people from that perspective. And so we are very broad in that we are one of the top 10 defense companies in the world and one of the top 4 within the United States. So definitely a very broad base from that perspective. And with all that, there's different things that we touch and we institute. But who are we is really what a lot of people kind of ask. And for Northrop Grumman, it's all about end-to-end capabilities. And you may say, what does end-to-end really mean? It means that we build the actual sensor. Here you're seeing the James Webb Telescope. But we're also a part of the comm system to bring that telescope down. We're also a part of the evaluation of what is being performed, how the system is being performed. The James Webb Telescope was built and constructed by Northrop Grumman, in which we took components from around the industry. The mirrors that you see there came from Ball Aerospace, located in Boulder, Colorado. So it's about creating that end-to-end ability to tell what is occurring so that we can really protect our nation and advance discovery. It's more than just that. It's also about advancing the discovery, which the James Webb is a perfect example of that. But what we really dig our heels in with Northrop Grumman is we're engineers at heart. And that means we like hard problems. The James Webb Telescope, you know, I love this image because you can see the size of just one of the mirrors as you have a person standing in front of it. And remember, we were putting together 18 of them to create one large conical mirror so that we can therefore peer deep into space. That is what we like to do. We look for the hard problems to try to figure out how we can solve them so we can protect the nation and really figure out how we can push forward from there. It makes it very exciting from that perspective, but there's challenges. So I am in the space sector of Northrop Grumman. And so really when you look at the space sector, that means that space is more than just what we're launching and what we're putting into space. It's also about the ground from that perspective. So if you want to start at the bottom right, Northrop Grumman has what we call Antares rockets and resupply that we send to the International Space Station. So we're in the rocket business. But yet we also have in that bottom mobility and logistics. And you're looking at the satellite, in which it's one of the first of its kind that actually go up, latch on to another satellite, refuel it, or becomes the power source for that satellite to extend the life, they extend the operations. But we're also a part of deterrence. There's threats around the world. And we want to ensure that we are protected and looking forward as a nation from that perspective. And so that is where we are a part of what we call the intercept programs when it comes to intercepting ballistic missiles. But then there's still intelligence, surveillance, reconnaissance. It's about the computer systems that are built to let us understand what is occurring, what the threats are around the world, and how we pull them together. Satellite communications, a large portion of our secure satellite communications, Northrop Grumman is a critical part of. But like I said, it's more than just the nation's protection. It's also about exploration and science. We are working on the habitat for the moon, the HALO program, where we're building that habitat in which it will orbit the moon, and it'll be a part of the lunar landing programs from there. So it's all about how do we find difficult problems and try to figure out the ingenious ways of taking care of them and going from there. But we also understand the threats that we have, unfortunately, in the world. And so how do we protect ourselves and ensure we're well positioned from there? But one of the key things you hear here is a diverse set of skills that are required. Everything from RF engineering, because how do you communicate with your satellites, RF antennas, so forth like that. Systems engineering and how you overall bring designs. Optical engineering, when you're talking about OPIR sensors, which have optical telescopes on them. Habitat, human habitation, when you're talking about exploration and science. So we're a broad breadth company from that perspective. But from my perspective, I'm very heavily in the space security, OPIR, how we protect our satellites, the missile warning and defense components. That is a major component that we do here in the Colorado area. Out of Buckley Air Force Base located in Aurora, Colorado, Schriever Air Force Base located in Colorado Springs, in which there's a large portion of the Space Force and the Air Force that's located here for this particular mission set from there. So it's a very broad breadth of which the space portfolio accomplishes. But it's how do we take capabilities and expand it? How do we take it and go from there? So that's where you're talking about Space Development Agency, where very similar to what a lot of you have heard about with Elon Musk and the Starlink. The Space Development Agency is also launching a large amount of comm satellites in low Earth orbit in order to accomplish that mission. So it's a part of how do you transport large amounts of data to create a secure comm and no matter what the threat is occurring. It's as well as the tracking. How do you find and know if a threat is being launched toward the nation or our allies, and how do we ensure we are protecting and letting others know that that is not what we want in the world. The James Webb Telescope, as we talked about, this is one of the great adventures of all. You're talking about that it is outside of the orbit of the moon, in which it's in a stable position at a Lagrange orbit in order to peer into the depths of space. You're talking about a complicated project put together in which there is no servicing. There is no ability to service it like we did the Hubble. It was a one-time activity. And that type of systems engineering, testing, process, procedure is what we're known for in order to take those heavy challenges on. But then you see the mission extension vehicle. How do you make sure that your DirecTV, your other things, satellites that you utilize that are reaching their end of life, how do you extend that? And that's where we actually latch onto another satellite in order to provide the power and the fuel so that it can continue to perform its mission. Because once again, when you go up into space, you want to ensure that we're not creating debris and trash. We want to be a part of that solution. And that's really what we're all about from that perspective. I am specifically heavily involved in what we call the Next Gen Polar program. These are a group of satellites that are in a HEO orbit, looking to detect when launches occur around the world. It is a part of how do we ensure that we understand the threats that have occurred, and how do we make sure we understand if we need to use an interceptor to take it out, or if we need to retaliate because of a threat that has occurred. It's all about giving the possible to our nation so that they understand what is occurring. But it's also ensuring that we continue to push the art of what is needed for our nation from their perspective as well. So really, from a Northrop Grumman perspective, we enjoy everything that we're involved in. We enjoy the depth of capabilities. And now we're excited about Halo. We're excited to be a part of the Artemis program, in which those solid rocket boosters on the side of the Artemis that will launch were built by Northrop Grumman, right there in Utah, so right next door to us here in Colorado. And the Halo program will be in that orbit around the moon, helping to provide that capability. And this is teaming across the nation in how we do these things. But that end-to-end, which is once again what we talked about, that's whether you're dealing a payload, which you're talking the microelectronics, the components, the crosslinks, the inner workings, all built to survive the rigors of space. Every orbit of space, whether LEO, MEO, GEO, or HEO, have a different radiation signature, a different challenges for operation. And so as you build payloads, you have to understand that. As you build spacecrafts, you have to know how much fuel is required for a LEO orbit, where you're doing more constant station keepings compared to a geosynchronous orbit, where you're in a more stable position, mimicking the movement of the Earth. It's about that full manufacturing, the integration and test, the full capability development. And Northrop Grumman is a global company where we are looking to take the best of ideas and bring them together from that perspective. But then, once you build the payload and once you build the spacecraft, you still got to get it into space. And that's where I'm talking about that launch capability, actual launch vehicles, suppliers, components, everything from there. But now you have it in space, you still got to get the data down. And that's where we talk about ground stations, and radars and tracking, the actual mission control of how you command and control that satellite and recover from anomalies, because anomalies unfortunately always occur. Issues that occur in space, but how do you understand what has happened and how do you can fix it? And so Northrop Grumman, what we have always done in our organization is offer that end-to-end integrated capability, but also we can give particular ones for necessary executions. So each one of these is what we're talking about from that capability. But what it gives is it gives our engineering team and our full support staff team a large amount of areas that they can take advantage of and get the experience in. If you are a software engineer, you can start in software engineering, working heavily in the operations, working with mission command, ground stations. But yet that skill set is still transferable to the payloads or to the spacecraft, where you still have software, other capabilities, hardware engineering, radar, and everything is a part of that capability. And that's where it comes so critical for our ability to kind of take advantage and get an understanding of what people are looking for and how we can go. But that is, we have a lot of creative ideas and opportunities from there. So that's just a bit of what we do. And then the other part is, like I said, we're a nationwide and worldwide corporation. Here in Colorado, right here, we have over 2,000. We have over 2,000 employees now. We've now crest over that. That is what we're talking about, as in, where do you want to execute and do your career development? There's often a lot of opportunities for us to get you in that location. We are in every state of the union, except for a few, but we're working to get those covered as well. That's really what it's about, of opportunities and where we go. Like a large amount of things, where the largest populations are is where we have our most amount of people, but we have a lot of traditional basis of areas that we've done a lot of operations. So that's what I wanted to kind of give a little brief introduction of what Northrop Grumman is, what we're about. But I wanted to give more time for you to kind of ask questions. I can definitely go more into what we're doing, particularly here in Colorado, but also what we're doing nationwide, but really about space from that perspective. So I hope that's a good teaser so we can get some questions from you.
Great, thank you, Calvin. So maybe I can start with some questions. Could you you mentioned kind of the exciting things and projects. What do you recommend? What is your advice to students kind of looking to start their careers and maybe going into some of these areas?
What I always tell people, that the best thing that you can do is a science, technology, and engineering math degree, a STEM degree. What that means is that it shows that you have an ability to understand complex problems. And once you understand complex problems, what I always tell people is have flexibility to try different things. I'm a computer science degree, but now I run large amounts of programs. So am I programming as much as I used to? No, not at all. They probably want to keep me away from programming now the way I used to. Systems engineering, for me, brought a lot of different disciplines together to solve complex solutions. So by getting that initial STEM degree, now that allows you to enter into various fields in order to figure out what you enjoy. And that's when I then went off and said, I enjoy large systems. And that's when I went and got my master's in systems engineering, because I enjoyed putting multiple programs together from that perspective, multiple disciplines to help solve problems. So what I always tell people is STEM is very good to start with. Taking that, and now it allows you to kind of expand and go elsewhere from there, and being flexible. But if you have a passion for something, that's no doubt, then let's go all in and understand that we're flexible enough that we can have someone who's very specialized. I have engineers who have only done RF their entire career, and they've loved it. And that's what they want. That's what they enjoy. And that's what I want to make sure we are, as a company, taking care of and taking advantage of from that perspective. So I always say, be honest with yourself and figure out what you like and what you don't like, and then be open to try those new things from them.
Great. So if I heard you correctly, you said the STEM degree kind of is the key that can open multiple doors, right? And you don't have to necessarily be pigeonholed that if you did mechanical engineering, you're just going to be doing struts and wheels the rest of your career, but at the same time,
absolutely, because what it just shows is that you have that ability to be diversified. Absolutely.
But often what intimidates students is that first job, right? How do I get my foot in the door? There I imagine you do have to rely a little bit more on what you just did your degree in. And even though Colorado's great in terms of aerospace industry, it's a lot of big players, like you guys, and also the Lockheeds, the Raytheons and such, the Ball Aerospaces, but sometimes it's hard to get your foot in the door. You feel like you're sending your resume into a black hole in a way when you apply through the main website. Do you have any advice on kind of getting that foot in the door to get that initial job?
I always ask, all of the big players have an intense internship program. Take advantage of it from that perspective. We often have representatives that come to various universities, but we also have online submission for internships. It's a great way for two things. One, if you are someone who may or may not want a clearance, it's a way to start one, a secret clearance or something like that, so that you can get exposed to different things. The internship program also allows you in many ways to get a little sample of different things. So let's say you're a mechanical engineer. We may have you interning with a mechanical program, or sometimes we do it with a computer program, so you can see the variety of different instances from there. It's about taking advantage of those as an entrance. And then there's a lot of programs, like for Northrop Grumman, we have a program called Pathways. And what this program is about is that we hire you and we take your initial degree, and that is what you're assigned to for your first year. But did you hear my key thing that I said only for your first year? Then after that, we rotate you to other positions within Northrop so that you can get a broad breadth of what we do within the organization. And so you can have an experience of different things. And you now get an understanding of, well, I really enjoy integration and test. Even though I'm an electrical engineer, I enjoy testing and going through the procedures and the process. Now that allows you to kind of focus in. And all of the large companies have similar programs such as that. So you ask when you get that interview opportunity of, hey, do you have a rotating or a mentorship program or things like that to kind of get you a little bit of a feel in different locations? And a lot of times, if you start with the internship, that means that you may intern in a software house and you may say, I really like that. And that's what I want to try for my first instance of work. But be comfortable knowing that if you want to change, that is what we're here to embrace in many of the companies of we have different areas that you can try at a different realm. Great question, Mark.
Okay, any questions from the audience, students? Don't be shy. We got a good amount of time for discussion here. So.
All right. Well, we have a little dead time. Unless you're about to ask something, Zach. Go ahead.
Yeah. I was wondering if you guys have any like groups or focus in robotics. I currently I'm a computer vision engineer, and I have a lot of interest in computer vision and robotics. I kind of see your payload there looks pretty similar.
Yeah. One of the big ones that I would mention, let me see if I can go back one and find it. This is a lot of robotics. What you're seeing here, it's a mission extension vehicle. So you're talking about articulation of arms in order to latch onto a vehicle. You're talking about how you would articulate and make movement. So that is a heavy portion of it. And you're talking about doing it in space, which just makes it more exciting, of course, as you can imagine. But also from a Northrop Grumman perspective, we also do it for the Army, for a lot of their different programs, as well as for the Department of Homeland Defense when it comes to dealing with threats from that perspective of how you can use robotics to kind of address. So robotics are a critical component of how we want to execute and where they can be utilized. And so we have in Baltimore a heavy robotics team. California, LA, California, we have a heavy robotics team, as well as we have the software house here in Colorado that kind of addresses how the robotics are programmed, how they'll come up to each individual vehicle, make maneuvers from there. And then anytime you work with NASA, there's a robotics nature in that as well, especially from when it comes to International Space Station, which we work with a Cygnus resupply, as well as with the HALO program. So robotics are critical because there's many things that we do not want to put astronauts or personnel in danger. And that's where we've been leveraging that from that side. So if you ever look online for Northrop, as well as Lockheed and other companies, you'll find that capability there.
Very cool. Good to hear the software is here because
that's the great part about software. You can be located anywhere. And a lot of times when it comes to spacecraft, just being honest, when you have a high bay in which you have that that creating the vacuums of space, that's a lot of facilities. So a lot of those are in certain locations, like ours are in California, Los Angeles Air Force area, as well as in Baltimore, where we have a lot of high bays, in Gilbert, Arizona, where we have major high bays doing large construction and capabilities of satellite spacecraft from there. So the infrastructure often drives you, but from a software perspective, we can go anywhere. We're great people.
And Calvin, are there, you said, a lot of the opportunities probably involve a security clearance. Are there non-security clearance careers that you can also do at Northrop? There
are a great deal. We do a lot of work with NASA, which doesn't require a security clearance. It just requires, a love of the solving of technologies. We have a large amount with Homeland Defense and with civilian organizations in order to deliver capability. So it is definitely not a limiting factor. It's definitely one of those that gives a great deal of opportunity outside of having a security clearance. It's just the security clearance we can take you in and show you even more cool stuff.
Hey, other questions? Don't let me dominate this. I could go for hours here. But please, I'm sure you guys, some of you have questions and, feel free to ask about anything. I think, one of the reasons we invited Cal here is not just to talk about Northrop, but maybe also just about,
The
career
industry.
opportunities,
Yeah.
how to advance yourself in different ways, or maybe what the future holds, right? So.
And I think as you tease about what the future holds, that's a great point. More and more is going to space, whether you're talking GPS, whether you're talking Starlink and comms, whatever you're talking, that is really what's driving a lot about what we're doing. So there's a lot of great opportunity there outlined within the organizations, as well as on the ground of how you take advantage of it. So there's a great deal in which the technology advancements we're pushing will not stop.
Who do you guys use to launch your hardware into space?
We use a variety. We have United Launch Alliance, ULA, which is based here in Colorado. They are a conglomerate of Boeing and Lockheed Martin, where they launch a large amount of our equipment for the DoD. For the International Space Station, we actually have our own that we launch out of Wallops Island in Maryland, the Antares rocket, which is what you're seeing here. Where we'll launch that to the International Space Station from that perspective. We also use the SpaceX launches for some of our payloads from there. So it is really oftentimes what the government will do is that they have procured us to build a satellite, and then they'll do a separate contract for who will launch or procure. And then for our space launch, we have an individual contract with NASA to do the resupply for the International Space Station, as well as we are part of the Artemis program from there. So that's the great part of what we're seeing across the board is we're introducing more launch vehicles and providers into it. And then so from a Northrop Grumman perspective, because we're doing the Antares and the Artemis, that means we also build our own rocket boosters for our global defense systems of ICBMs and interceptors from there. So it is definitely a nationwide thing from there.
I have a quick question.
Hi.
Do you guys specialize in any of the optical hardware on satellites, or do other companies typically do that for you guys?
It is a mixture, depending on the item that's being done. For this satellite that you're seeing here, this is a geostationary satellite on your left. We built the optical sensors, and then we worked with a third party to get the telescope. The telescope used, but with the actual opticals, were built by Northrop Grumman. As we were talking about the James Webb Telescope, the actual mirrors were built by Ball, the beryllium mirrors. So therefore, they built the mirrors and sanded them into position. But then the optics that are built back in that were kind of focusing in the light were built by a combination of Northrop and other third parties. So it's kind of, as I like to say, user defined. What is the actual need? If we have something kind of off the shelf, on the shelf, ready to go, then we'll build it ourselves. But with the Space Development Agency, those are other ones where we've gone and found what we call are the lowest cost, best option in order to build that capability. But we do have an optical house because often as the integrator, you want to ensure as a system engineer, you understand why and what something was built like so that it's meeting your requirements. And so you therefore still have an understanding. So we do have a large optical team that's a part of our organization, whether it's on space or ground as well, because we build ground telescopes from that perspective as well.
Very cool.
Okay.
Great, thank you. Another student question or anyone else question?
I guess I can have another one. So you said you have an optical house. Can someone typically join that without getting into the defense aspect and focusing solely more on the space exploration aspect?
From a yes and no. There are more commercial vendors asking for optical sensors in space now. I think like all things, a lot of times what you'll see is that the government helps spur technology, and then the commercial industry will now see the usefulness and kind of go from there. And so just like, if you think of your GPS or your initial comm satellites, a lot of those started off as military. And now they have commercial users who can see how they can be expanded from there. And we're seeing the same thing when it comes to a lot of optical sensors, where people are seeing that they can do surveying from space in order to get an understanding. So that's something that they're now requesting more of, and we see an expanding market. But then when you come from a ground perspective, it's very heavy a lot of times NASA, as in looking and trying to understand what is happening or in space or in other areas from that perspective. So right now, I would still say it's a little heavily dominated by the government, either NASA or the Department of Defense. But we are seeing more commercial come into it, in which we're offering these same type of capabilities. But NASA, from a civil space perspective, is massive when it comes to optical. When you're trying to observe climate change, changes to polar caps, fire damage from forest fires, weather changes, things like that, it's always a part of their mission set of how do we help humanity.
Okay, I'll throw in one more question here, or one of many. If you're in a kind of specific market, right? Because a lot of your customers, right, are the government, maybe government agencies like NASA. So it's a specific marketplace, but it's still a marketplace, right? You still have competitors. Could you maybe talk a little bit about that? What is it? What is that? What is that like? What do you do to be better than your competitors? What's the competitive landscape like? What are the kind of main things that lets you guys be the leaders you are?
I would say one of the main things, first of all, there are a large amount of competitors. And you're talking about worldwide as well, because we have BAE, which is a British company, is very heavy in the Department of Defense. Leonardo, which is an Italian company, very heavy in the Department of Defense and government contracts from that perspective. Lockheed Martin is the largest defense contractor. Raytheon is second. So you're talking about a large amount of opportunities within. And what Northrop, we have always prided ourselves on is we are engineers at heart trying to solve the hardest problems. So oftentimes, when we pursued the James Webb Telescope, we offered a solution that was considered innovative. And that's what we're always looking to push for. So we're very much known for our end-to-end capabilities in order to bring innovation to it. And often our competitors will say, we want to use Northrop Grumman for this payload. This payload that you're seeing here to the left was built for Lockheed Martin. It's on a Lockheed Martin satellite. We are simply sub to them in order that we built the payload for them to be utilized, because they know that we have a very good skill set. But the same thing is Lockheed Martin is very good at overall integration. So there's these good telltale signs of how companies give and take in order to bring the best solution. But the market is extremely competitive, and that's a good thing, because it gives more to our employees to have opportunities for growth. And it helps spur innovation. When you have a large amount of competitors in a field, that really means that the government or the civilian industry or NASA can make a choice that is the best cost and the best capability. And that's what has really pushed us, is the amount that we spend in innovation. Northrop Grumman spends billions of dollars each year on what we call research and development. That's internal money to try to figure out how do we improve our optics to deal with the Van Allen belt radiation at NEO or different things such as that. How do you improve your technology from that perspective? That is really one of the big investments that we push for, and our competitors do the same thing. And we often say we're competimates, in which we are competitors, but as you can see, we work together on a large amount of projects because it's still one goal: to develop and field the best product possible for whoever's coming out there. And that's really where our focus is built. And so therefore, each project is a different determination. Part of my job is to figure out, are we the best solution set for the government? And if we are, then we will propose it. If we're not, can we help someone else improve their offering? Can we work with them from that perspective? That's really what my job is as a director, is to make those decisions of how we give the best bang for the buck for the country. if it's for my particular industry, which is heavily NASA and Space Force, or how do we make sure we're giving it from that perspective? So it is extremely interesting. And Ball here in Boulder, very good at optics. I mean, you can see that beryllium that we used on the James Webb Telescope. So that's really where you'll find what I call our specialized houses of development. There are some people who are focused solely on building an optical telescope, and they are the best at it. So therefore, you may often just say, I will take their component. And so therefore, it's what do you enjoy doing? Like I think I heard Zachary talk about robotics. There are some companies who are immensely invested in robotics in different areas, in which that may be where we go and pull them for that capability, or we develop it in-house because of the specialized nature required of it. But it is a targeted decision each time.
And the main kind of, is the proposal the main mechanism that you kind of get your customers and convince your customers and you know?
The proposal is the main one. We often will do, when we talk about research and development, I might do as I call develop a solution to demonstrate it to the customer, to say, here's what is the art of the possible, and then we'll see if we can expand. But the proposals and the definition of what they're trying to solve, that really defines it. For example, with the James Webb, after they launched Hubble, they said, you know what, Hubble was great. It's in low Earth orbit, so we're still dealing with a little bit of perturbations of where we're trying to point because of the movement. Low Earth orbit, that means that it is moving constantly at a high speed, so we don't have an ability to dwell into a certain location. So after their experience with the Hubble, the NASA came out and said, we want a satellite that's further out and able to really dwell on a particular topic or target, excuse me. And so that's what helped spur the James Webb Telescope. And that's why it's outside of the orbit of the moon, in order to kind of have that ability to really dwell and look at a particular location for a long period of time. And that's where those requirements come, and then you develop specifically for there.
So communication skills and writing, being able to do a good presentation are also part of the career.
Yeah, if you thought you were never going to write again, sorry. You have to be able to communicate your solution to others. I would hate to have the greatest solution be lost because we can't explain it or we can't demonstrate it to someone. Like all things, we have to be able to show, why is this worth the investment and the time that is necessary of precious dollars and personnel in order to execute on something. So our ability to write white papers, our ability to work and write on your doctorate or your master's thesis or things such as that, these are skill sets that will still be utilized all the time. And that's why I say a lot of times, what I'm looking for is people who can do research, people who can understand and pull data and then synthesize it into a solution set. That is what you're doing right now with your STEM degrees. That is what you're doing in your undergrad and your grad, and you continue to build to your doctorate as you move forward. It's a great point, Mark.
So when you are evaluating like a potential candidate, are you focused on the GPA? Are you looking at kind of performance in key classes, or experience, projects, internships?
We are looking for GPA is always critical. That helps, but it's not the be all end all. But we are looking for those who have illustrated skill sets throughout their university days or whatever. And that's internships. If you've done internships at different locations, that means you understand different work environments and different executions from there. As I call them, your ability to highlight critical classes you took that illustrate an industry trend or an understanding to kind of push the technology and innovation. That's what we're seeking from that perspective. But make no mistake about it, we still need good grades because it shows that you have the basis to put that to work. And you understand the outlines of a problem in order to find a solution. So that is definitely one of the things that we're seeking as well. But I would say it is about a depth of knowledge, depth of understanding. Northrop Grumman, we have a large amount of former military personnel. And a lot of people ask why. It's because if you're working in the defense industry, they understand the difficulties and the challenges of being in a hostile situation. So therefore, they make sure that we develop solutions that make it easier and safer for the operators from there. Same thing of why do we hire a lot of NASA scientists or people who have done a lot of research projects with NASA, because they understand what the end goal is and how to get there. And so that's why we always say, seek those internships, seek that ability to get that little bit of exposure to something else, because it helps diversify and illustrate your resume. And oftentimes you'll see that you'll walk right into a job.
Yeah, well, one of the things we try to do across the college is kind of experiential learning, project-based learning. So students have some ability to pursue different kind of projects and show what they can do outside of just, being told to follow things. I think like Aya's on a space rover team for her senior design project. So it's a lot of cool experience. And I always tell students that you're going to do great in an interview if you can have something that you can talk about that shows, not only your skills, but your interest and how you pull different things together. So
your ability, Aya, to kind of point that out during an interview, that's a separator. That's what we're talking about. That was great senior thesis. That is what we're looking for in order to say, oh yeah, you're ready to jump into this. We have something even harder for you to work on tomorrow. Welcome.
Yeah, I was going to ask about that because throughout COVID, I kind of lost the opportunity to get internships. So I have one internship, but a ton of projects that I took on by myself just because I knew I was losing opportunities.
And that's where I say, even in your resume, if you can give just a few lines to talk about that project, especially if it's something specialized, like if you're looking at a robotic rover for space, that means you're already thinking about contamination and dust and other things that may occur, and you're showing that system level thought. And that's what you're trying to highlight in that resume as you go through, because we did have a lot, just like you, who lost that opportunity for internships as we went through the COVID shutdowns and those variations. And it's not a lost opportunity. You're already thinking of it perfectly. Great job.
So if I can ask you one question as kind of an academic administrator, right? So you mentioned kind of all the STEM degrees sort of, are important and you can go wide things. Since we're also as universities competing with others, it is a systems engineering degree. Is that something that would be valuable or would maybe give us access to students who want to pursue those kind of careers, and how would it be seen from your end? Or would you prefer to see kind of maybe mechanical engineering and a few other systems classes as opposed to a whole degree around systems engineering?
Well, you ask a hilarious thing, because I remember when I was going to school, we had the argument of is system engineering real. We've now decided it is. But it is. Systems engineering as a course requires a combination of business management, understanding of other disciplines and how they integrate and deliver a particular program. And it's heavily requirements based. I think a systems engineering program is still very valuable in order, because you are taught that holistic view of how to solve problems and get different components to work together. Whether how is software's test going to integrate with the mechanical engineering and the hardware components integration, which often we can learn if you're just a mechanical engineer. You take a couple systems classes, you're going to get a good understanding. But then there's still that variation, or there's those slight misses from that perspective. As well as we find that sometimes the personnel who want to go into systems engineering didn't necessarily feel they enjoyed as much straight electrical or things like that. So it gives them another way that they can be a component or a part of a project and bring it together from that perspective. So I'm still selfish, and I think systems engineering as a discipline is still very useful for a university. And I still think it still delivers a large amount of projects, because it comes back to how are you integrating what we see here, a payload with a spacecraft, how with the launch adapter, with operations. They all come back together, and our ability to develop in silos just don't exist anymore.
So if I interpret you right, would you want to see like somebody does like a bachelor's electrical or mechanical or CS, and then they do like a systems degree, master's of engineering or master's of science? That would be the that's the preferred method.
because now they have the understanding of the detail of one and the larger picture of the other.
Good. I'll go straight to our dean and tell him that's what so we've been talking about stuff like that.
We're ready for it. I'm ready. I'll come join you.
Okay.
What about like a one specialized class at the end of our degrees for systems, just to get a feel for it?
I think that's still very important. It gives you a good understanding. And I think that is critical. I often tell people also, you should look at a business class, a overall finance class as well as one of your electives or something, because everything comes around to, if you have the greatest idea, but you don't understand how to fit into a budget or how to estimate, it's not really a great idea. It's an idea that will get canceled, because we've so all those things go together. So even that one class at the end of your degree, it will give you enough that it helps you understand as you're going and you're working with others. So no, great idea as well.
Any other questions from students or anyone?
I see I've got a question online.
Oh, yeah.
Let's see. All right, didn't want to miss them. We'll start from the top here. Okay, I've noticed a lot of companies have rotational programs. Northrop, are people allowed to choose what they like to experience in? Yes. We often have positions that are open in which you apply particularly to that position. And then you say, I would like to go into the rotational program. And then as you rotate, you are a participant in choosing where would you like to rotate to next? Let me go and see if I would like to rotate into this program. And with our pathways managers, they go off and then recruit for you to get you into that field. That is critical, because as a young engineer, the biggest thing we want you to have an opportunity of is to see things, because then you really can kind of choose where you go from there. And then you can become an old seasoned head like us and really get in the way.
Let me ask you one more that I promise is my last one. But you're in a leadership position at a technology leader, right? So to sustain in that, you really have to kind of be ahead of the game and always looking forward to what may be the next technology on the horizon. So two-part question: what do you do to do that? What do you do to stay up to date? And what do you see maybe on the horizon that would have the biggest change in your company or industry?
So curiosity is what I'm hoping you're learning in school right now. That is the biggest one. I still get delivered tech magazines in which I'm thumbing through, I'm reading, figuring out. I am still going to conferences to see new ideas that are being presented. I still go on YouTube and just YouTube interesting things that are happening. Like the Line City in Saudi Arabia. I just find that very interesting. They're going to build a 100-kilometer long city across the, curiosity. That's what it's all about from there. Because we are constantly learning and we're constantly looking to figure out new things. From our perspective, one of the big things that we are seeing as the technology is we're trying to figure out how do we ensure we have ethical artificial intelligence. Ethical artificial intelligence is not that I think a machine's going to take over and start running the world. It's how do we understand how machine learning or artificial intelligence made its decision? How did it come to that decision? How do we continue to make sure it's learning and going from there? That is one of the big things that we will continue to go forward with across our industries, whether they're civil or DoD. Why? Because it helps speed recovery. The faster we can have a machine do a task for us to save a satellite or to maneuver a car, many of your cars have a little bit of this, it senses something and makes a maneuver out of the way. This is what we want to increase our safety to allow us to focus on other things. So that's one of the big ones of how do we make sure we have an ethical AI of that we understand why a decision is made so that we can ensure we can modify it and continue to with that learning perspective. Because that is where we will continue to then take those leaps in processing, those leaps in capability. and those leaps in safety, because oftentimes a machine can make a rapid decision to make sure we're safe, and that's not a bad thing. But
Yeah.
stay curious.
AI, that's definitely something that's on a lot of people's minds, and really affecting a lot of different industries. So it's
Mhm.
interesting to hear you say that, or not surprising in some ways, but okay. Any other questions or discussion points, comments? You have a rare opportunity here where the speaker gave up a lot of time for discussion. So please feel free to take advantage.
Oh, come on. You don't often get to see cool pictures of James Webb and satellites grabbing other satellites. Come on, people. I really want to thank y'all for the time, though. I think you asked a question. I saw a question on a minor in physics or math are always sought after. We have, I know for Northrop, we hire a large amount of mathematicians who are a part of our various teams. I have 2 on my RF team. So a minor in math or a minor in physics is one of the core basis of a lot of what we do. And so therefore, it's just like with if you're a traditional engineering, it once again shows an ability to understand a problem and go in that direction. So please don't feel that if you're a math major, you can't get a job. No, that's not true. Or a physics major, we are seeking those as well, because you are understanding how to utilize and understand complex problems for solutions. So that's definitely another great capability from that perspective that's sought after.
Great. Well, thank you. Well, let's officially thank our speaker as best we can in the virtual format. So thank you very much, Calvin, for your time and wisdom shared today. So thank you, everyone. And for those of you, for the next seminar is going to be in 2 weeks, November 15th. So look out for that.
And I look forward to seeing y'all. I know I've got to come on campus a couple times. I got to harass the doc there and make sure that if y'all need anything else, we're definitely a part. And I really do mean it. Please push. And if you're putting out for jobs, know that sometimes it's a black hole, but we are actively and trying to add. You are what we need for our future. And I can't thank you enough for all the things you're doing for your degrees and your focus area on your careers. So we want to make sure we're here to help from that perspective.
Thank you so much. Thank you.
Thank you.
All right. Thanks.